Hello everybody and welcome back. We're on to part C of the year 2000 Fermat paper. So that's the University of Waterloo's grade 11 level paper. So everybody except those in grade 12 are able to write the Fermat, so this is excellent practice. We're on to part C, so these are going to be the harder questions. In particular, we're at the very first question, so if you're just joining us, welcome. If you need a copy of the contest, of course, you can click on the link in the description below. But as I say, we're on to question number 21. So, question 21. Two circles of radius 10 are tangent to each other. A tangent is drawn from the center of one of the circles to the second circle. To the nearest integer, what is the area of the shaded region? Okay. Well, let's draw ourselves a copy of the picture and see what we can figure out. So we have two circles. Now, I don't have a compass feature as far as I know on bamboo paper, so this is about as good as it's going to get. I'll label the centers here, and we have tangent here, and this area in here is the shaded region that we want. Well, the first thing we do is I would connect up the centers. I know that each of these guys has a radius of 10. So one side of this sort of triangle we're forming, call this point P. We'll call these A and B. So one side of this triangle is 20, and one side of this length is 10, and I don't think we're given any other information. No. But whenever I see tangent circles, I almost automatically connect up their sentences. Their centers. Now, another really nice thing, you'll notice I drew this line here, B, to the point of tangency, because, we'll change to a different color, the radius and the point of tangency, they hit the tangent line at exactly a right angle. So, I've got a right angle triangle here. So APB is right angled at P. We have 10 and 20. So AP squared is going to be the hypotenuse minus the other leg. That's going to be 20 squared minus 10 squared. And that's going to be 400 minus 100. So AP is going to be the square root of 300. But I can write that as 3 times 100. Separate that out. Square root of 3, square root of 100. So we're looking at 10 root 3. And that's actually pretty interesting because the side lengths here are in the ratio 1, root 3, and 2. So this is a 30, 60, 90 triangle. Oh, that's nifty. Okay. Now, suppose I didn't know it was a 30, 60, 90 triangle. It is, and that could make my life very simple. But let's suppose I didn't know that. Okay? I want the area of the shaded region. Well, the shaded region is going to be the area of the triangle. So APB minus these two sort of sections of the circle. Minus both pi slices. So both slices of the, we don't need the word pi in there because we're going to be using the number pi in a little bit. Minus both of those slices. Okay. So if I knew the area of the triangle, which I do because I know the base is 10 and the height is going to be 10 root 3, and if I knew the areas of these two slices, which I will, and I'll show you why in a moment, I could figure out the area of the shaded region. All right. So let's let angle PAB be called theta. So this guy in here is theta. And this guy in here is going to be, well, the sum of the interior angles of a triangle is 180 degrees. We have a 90 accounted for, we have a theta, so this is going to be 90 minus theta. So the area of a slice of angle theta is just, what is it? Pi r squared is the whole thing. So I think it's theta divided by 2 r squared. Is that it? I'm trying to think here. Oh, there's got to be a pi in there too. Doesn't matter. Let's do it in degrees. So 360 degrees is the whole triangle, the whole circle, and we just want this tiny little portion, theta out of 360 degrees, times pi r squared. That's the whole thing. So if we were looking at a slice of angle 360, it would turn out to be the whole circle, and so it would just be pi r squared. So pi r squared, well, that's just really pi 10 squared. Okay. I don't know why I have that theta there. So that's the area of a slice of angle theta, which is fantastic. We also have the area of a slice of angle 90 minus theta. And you might be suspecting, and you might be suspecting correctly, that this theta and the 90 minus theta, they're going to cancel each other out. And that's why it doesn't matter that this happens to be a 30, 60, 90 triangle. But it is. We could show that this is 30 degrees and this is 60 degrees. And that would mean that this is 1/12th, and then this is 1/6. But we don't need to do that. Slice of angle 90 minus theta is, well, it's going to be 90 minus theta over 360 degrees pi r squared. So the area of the shaded region is the area of the triangle, which is 1/2 base times height minus theta over 360 degrees pi times 100 minus 90 minus theta over 360 degrees pi times 100. And we'll flip over to the next page to resolve some of this. Half times 10, that's going to be 5. So 5 times 10 root 3, that's 50 root 3. And then minus, and it turns out the theta and the 90 minus theta, they cancel out to give us 90 theta over 360, 90 degrees over 360 degrees, pi times 100, which is 50 root 3. These guys turn out to give us a quarter, and a quarter times 100 is 25. So minus 25 pi. So let's work that out on our calculators, because we're asked to the nearest centimeter or something like that, nearest meter, I think. So when I work this out on my calculator, I get about 8.0627. So to the nearest centimeter, I think it's 8. So the nearest integer, not centimeter. So C8 is my final answer. All right. It's a nice little question. Certainly there are a couple ways to approach it. Something that I think you should get in the habit if you had trouble with this question, the second you see a point of tangency, connect that with the center, and the second you see two centers with tangent for tangent circles, connect those up together. I think that's just a very good thing to get in the habit of doing. I mean, if it takes a few seconds, right? And it gave us the triangle that helped us solve the whole question. And if you just mindlessly do that, it's a few seconds. So if there was no point, then that's okay. You haven't really lost any time, but you could gain a valuable picture. So I think that's very good. And that's question 21. So we'll take a look at question 22 in the very next video. Thank you guys so much for watching, and I will see you all in the next video.